Welcome to IFERP, a forum where innovations and research interest could be supported and developed, prioritizing our mutual interest. In this video, we want you to dive into our world, giving yourself a clear insight into IFERP. But first, who are we and what do we do? Institute for Engineering Research and Publication, IFERP for short, is one of the world's largest non-profitable professional associations operating under the Techno-Elite Research and Development Association, TRADA, meant for research and development in the field of engineering, science and technology. We are one of the largest professional bodies for engineering professionals in India and across the globe, established in 2014. We extend to every part of the globe, with more than 28,000 professional members and 34,000 student members. Our growing membership at IFERP has led to an increase in members from Europe, Asia, Australia, Africa and the USA, fostering networking opportunities that strengthen ties within and across countries and technical communities. The mission of IFERP is to connect professionals at an integrated platform for growth to divert knowledge and skills towards the sustainable application of professional education and more. And our vision of digitalizing innovation processes through our professional networking services and more has pushed us forward to our achievements today. With our mission to make our academic services reach the top and grassroots level of institutions, we are funding colleges to organize conferences and scientific events, enabling researchers incubated at different areas of our country to directly contribute towards the transformation of India. IFERP simply connects engineers, exchange global innovation, and acts as a bridge between researchers and academics by organizing international conferences, world conferences, faculty development programs, webinars, seminars, providing membership, and more. Some of our conferences include WCASET Malaysia, WCASET Jakarta, ICAS ETAM APU Malaysia, and many more. We've also organised scientific events in association with renowned universities done in the past, with over 28,593 journal publication services, creating opportunities to get your research paper published in high impact factor journals such as Scopus Indexed, Web of Science, Google Scholar Index journals, ESCI, UGC approved, L Compandax, ISI, Shimago Index journals, and many more. To make our operations smoother and more perfect, we have been supported by our associated organisation, Association of Cloud Technologists, Global Association of Nanotechnology, International Association for Big Data Analysts, International Association for IoT, International Wireless Network Association, and World Association for Structural Engineers. We have also worked alongside several clients and partners both nationally and internationally like University Malaysia Sabah, APU Malaysia, UNJ Jakarta, MC University Thailand, Ajman University Dubai, PUP Philippines, IIUM Malaysia, ISU Philippines, FCPC Philippines, WCC Philippines SRM University, Galgotia University, Amity University, and much more government and private organisations in different countries. At IFERP, we believe there's always a better way to treat professionals, and that is what we do. If you would like to see more or go deeper on IFERP, you can visit our website at www.iferp.in.
Hello all, good evening, and I welcome you all to the webinar series on lecture series on machine learning. Our two keynote speakers, Pastor Arguelles Jr and Dr. Sharvari C Tamane, who were supposed to be joining us today, could not unfortunately join today's session due to personal reasons. So but however, Sharvari ma'am has sent her pre-recorded presentation to be played on her behalf. So before we proceed further, I would like to introduce Dr. Sharvari C Tamane more elaborately. And I welcome you all to the session 1 on Introduction to Machine Learning, Supervised and Unsupervised Learning. Dr. Sharvari C Tamane is currently the professor and head of Department of Information Technology in Jawaharlal Nehru Engineering College, MGM University, Aurangabad, Maharashtra, India. She has 23 years of teaching experience in Jawaharlal Nehru Engineering College, Aurangabad. She is working as a chairman of Board of Studies for Department of Information Technology at MGM University, Aurangabad. She has published a patent on profile-based mapping using cloud cluster security and deep learning recently in the Indian Patent Advanced Search System, Government of India. She has been awarded Best HOD of the Year at the CSI TechNext India 2019 Awards to Academia. She has been registered a copyright on cloud cluster security policy using DataCrypt based on ontology. Her research interests include big data analytics, watermarking, neural networks, machine learning, artificial intelligence, fuzzy logic, wavelet analysis, etc. She is working as an editorial board member of various international journals. Dr. Tamane has also edited books on privacy and security policies in big data analytics for smart and connected cities with IGI Global and security and private applications for smart city development with Springer Nature. She is the author of 9 chapters published by IGI Global and Springer. She is author of a book called Data Structures Using C and published more than 60 research papers in international and journals. She has also worked as a reviewer for many SEIE Scopus Index journals. She has been invited as a reviewer for many SEI and Scopus Index journals and also as a panelist for an international conference at Mauritius in the panel discussion towards Sustainable Development Goals in India and for the international conference at Women in Data Science 2019, which was held in Pune, in the panel discussion towards upskilling careers and career paths in data science. She has also been invited to many institutes to deliver expert talks and also delivered webinars, online seminars on various research areas. She has organized many special sessions in international conferences. She has also worked as a program chair for IEEE and CSI-sponsored international conferences, which was held at JNEC MGM University, Aurangabad. So I wish they were with us today personally, but due to unavoidable circumstances, they could not join us. So before I proceed further, I would like to thank both of them for at least, giving us the opportunity to collaborate with them in the first place, and also like to thank Dr. Sharvari C Tamane ma'am for sending a pre-recorded presentation on her behalf.
Good afternoon. I am Dr. Sharvari C Tamane, Professor and Head of Department of Information Technology at Jawaharlal Nehru Engineering College, MGM University, Aurangabad. I would like to thank Institute for Engineering Research and Publication for giving me the opportunity to share my knowledge in the lecture series on machine learning. So this is my topic of presentation, and these are the contents of my presentation for the webinar. So on these various contents, I am going to discuss. In the real world, we are surrounded by humans who can learn everything from their experiences with their learning capability, and we have computers or machines which work on our instructions. But can a machine also learn from experiences or past data like a human does? So here comes the role of machine learning. Machine learning is said as a subset of artificial intelligence that is mainly concerned with the development of algorithms which allow a computer to learn from the data and past experiences on their own. A machine has the ability to learn if it can improve its performance by gaining more data. Machine learning enables a machine to automatically learn from data, improve performance from experiences, and predict things without being explicitly programmed. So with the help of sample historical data, which is known as training data, machine learning algorithms build a mathematical model that helps in making predictions or decisions without being explicitly programmed. Machine learning systems learns from historical data, builds the prediction models, and whenever it receives new data, predicts the output for it, as shown in the block diagram. The accuracy of predicted output depends upon the amount of data, as the huge amount of data helps to build a better model which predicts the output more accurately. Suppose we have a complex problem where we need to perform some predictions. So instead of writing a code for it, we just need to feed the data to generate algorithms. And with the help of these algorithms, machine builds the logic as per the data and predict the output. Features of machine learning. So machine learning uses data to detect various patterns in a given data set. It can learn from past data and improve automatically. It is a data-driven technology. Need for machine learning. The need for machine learning is increasing day by day. The reason behind the need for machine learning is that it is capable of doing tasks that are too complex for a person to implement directly. As a human, we have some limitations as we cannot access the huge amount of data manually. So for this, we need some computer systems. So we can train machine learning algorithms by providing them the huge amount of data and let them explore the data, construct the models, and predict the required output automatically. The performance of the machine learning algorithm depends on the amount of data, and it can be determined by the cost function. With the help of machine learning, we can save both time and money. So some of the key points of the machine learning are rapid increment in the production of data, solving complex problems which are difficult for a human, decision making in various sectors including finance, finding hidden patterns and extracting useful information from data. So like this are the various key features of the machine learning. History. Before some years, that is about 40 to 50 years, machine learning was science fiction, but today it is part of our daily life. Machine learning is making our day-to-day life easy, from self-driving cars to Amazon virtual assistant Alexa. However, the idea behind machine learning is so old and has a long history. So we'll see some of the milestones of it. In 1834, Charles Babbage, the father of computer, conceived a device that could be programmed with punch cards. However, the machine was never built. But all modern computers rely on its logical structure. In 1936, Alan Turing gave a theory that how a machine can determine and execute a set of instructions. The era of stored program computers is there in 1940. That is the first manually operated computer, that is the ENIAC, was invented. Then the EDSAC and then the EDVAC. Like this it was invented. Then in 1943 a human neural network was modeled with an electrical circuit. In 1950 Alan Turing published a seminar paper on computer machinery and intelligence on the topic of AI. In this paper he asked, can machine think? And in 1952 Arthur Samuel, who was the pioneer of machine learning, created a program that helped an IBM computer to play a checkers game. It performed better, more it played. And in 1959, the term machine learning was first coined by Arthur Samuel. So the duration of 1974 to 1980 was a tough time for AI and ML researchers. And this duration was called as AI winter. In 1985, Terry Sejnowski and Charles Rosenberg invented a neural network NetTalk which was able to teach itself how to correctly pronounce 20,000 words in 1 week. In 1997, the IBM's Deep Blue intelligent computer won the chess game against the chess expert Garry Kasparov, and it became the first computer which had beaten a human chess expert. So machine learning at 21st century, that is in 2006, computer scientist Geoffrey Hinton has given a new name to neural net research as deep learning, and nowadays it has become one of the most trending technologies. In 2012, Google created deep neural network which learned to recognize the image of humans and cats in YouTube videos. In 2014, the chatbot Eugene Gutzman cleared the Turing test. It was the first chatbot who convinced the 33% of human judges that it was not a machine. Then in 2014, DeepFace was a deep neural network created by Facebook, and they claimed that it could recognize a person with the same precision as human can do. Then in 2016, AlphaGo beat the world's #2 player Lee Sedol at Go game. In 2017, the Alphabet's Jigsaw team built an intelligent system that was able to learn the online trolling. So it used to read millions of comments of different websites to learn to stop online trolling. Now machine learning has got a great advancement in its research, and it is present everywhere around us, such as self-driving cars, Amazon Alexa, chatbots, recommender system, and many more. So it includes supervised, unsupervised, and reinforcement learning with clustering classification, decision tree, SVM algorithms, etc. So modern machine learning models can be used for making various predictions, including weather predictions, disease predictions, stock market analysis, etc. So machine learning approaches are traditionally divided into 3 broad categories, depending on the nature of the signal or the feedback available to the learning system. Supervised learning: the computer is presented with example inputs and their desired outputs given by a teacher, and the goal is to learn a general rule that maps inputs to outputs. Unsupervised learning: no labels are given to the learning algorithm, leaving it on its own to find structure in its input. Unsupervised learning can be a goal in itself or a means towards an end. Reinforcement learning: a computer program interacts with a dynamic environment in which it must perform a certain goal, such as driving a vehicle or playing a game against an opponent. So as it navigates its problem space, the program is provided feedback that's analogous to rewards, which it tries to maximize. Now we'll see in detail about the supervised learning. Supervised learning is a prediction of labeled data. That is, the computer learns from past data where both independent and dependent data are present. It acts as a teacher to the machine. The variable which we predict is called as dependent variable or target variable, and the variables which we use for prediction are called as predictors or independent variables. On a very basic level, ML is not vastly different from the way humans learn. So for instance, if you show a pair of shoes and a pair of socks to a child, the next time he can point out a pair of socks and identify them. The higher the number of shoes and socks he comes across, the better he is at identifying them. So something similar happens in machines. The data about shoes and socks that have been fed to the system is called training data. There are many types in a way that machines can learn. So supervised learning technically means the learning of a function that gives an output for a given input based on a set of defined input-output pairs. And it does this with the help of labeled training data that consists of set of training examples. So like we have discussed in the example of pair of shoes and socks. So the picture of shoes and the name shoes are input and output respectively. And after learning from hundreds of thousands of different shoe pictures and the name shoes along with the same for socks when our system is given an input only. So we can use the function y is equal to fx to represent the supervised ML, where x is the input data and y the output variable, a function x that is to be predicted. So in any training data, the example pair normally consists of an input that is typically a vector and the desired output value, which we call supervisory signal, the meaning of which is easy to understand from the name. So supervised learning are classified into two basic categories like regression models and classification model. So first we'll see about the regression model. It builds a relation between dependent variable and independent variables. It is used for continuous data. For example, suppose we want to predict the cost of a house. The cost of a house is dependent on the parameters like number of bedrooms, bathrooms, and the area of the room. The cost of the house increases with increase in our requirements. So consider the parameters on x-axis and cost of house on y-axis. So the relation will be linear. The regression predictive algorithm does not identify a category of variable but assigns a quantity per number to it based on the historical data. It uses the relationship between an independent variable and a dependent variable from historical relationship data and predicts a quantity. A common example of this is predicting temperature on a particular day or predicting commodity prices with respect to time. The regression problem, the image shows a straight line. It is drawn through all data points in order to depict a linear relationship, which is called linear regression. Now, if the system encounters a value of age, say 10, for which we do not have anything training data examples, the system can still predict a numerical continuous value, maybe in between 1.3 to 1.4 based on the historical relationship. Then there are different list of regression algorithms available: linear regression, polynomial regression, stepwise regression, ridge regression, lasso regression, and elastic and random forest. Like this, the different models are there. Then comes the classification models. Classification models are used for predicting categorical data like yes or no, or 0 or 1, or small, medium, and large. So it classifies new data and places this data in the category to which it belongs to based on the historical data. For example, if we want to predict admission of students into a college, then we must train our model with some historical data which consists of details of students who got admission into the college and who failed to get the admission with parameters like grade, rank, score, etc. As the name suggests, classification algorithms undertake the job of predicting a label or putting the variable into a category. So for example, classifying something as socks, as we have used in the previous example, An everyday application of classification predictive algorithm is the spam detector in emails, which will identify attributes that help it categorize an email under spam or not spam. The characteristics of the classification algorithms are, they can be classified into one or two or more classes, or a problem with two classes can also be called a binary problem. A problem with more than two classes can be called a multi-class problems. So here we have the various classification algorithms like logistic regression, random forest, decision trees, SVM, naive Bayes, and k-nearest algorithms. Now we'll see the different steps involved in supervised learning. First step is determining the type of training examples. For example, here deciding on the type of shoes and socks, images or cats and dogs, examples to be fed for training. Second step is prepare or gather the training data. So all the input and output values labeled from have to be gathered, and the set should be representative of the real world applications of the function. For example, if there are 30% of a particular breed of dog in the real world, the percentage in training data should not be 60%. So even for semi-supervised learning, although most part of data is not labeled, it should still be driven to real world conditions. Next step is determine relations between input feature and representing learned function. The input feature in practical cases will not be simple as shoes and socks, but complex with multiple features, thus used typically as vectors. So this means the accuracy of the function may vary. The number of features should be optimum for optimum accuracy. Next step is select a learning algorithm. Selection of current algorithm matters in both supervised and unsupervised learning. A variety of algorithms are available for selection, and there is no single perfect one, but the suitable to the problem's need should be selected. For example, the linear regression model can be selected when the relationship between variables is linear. Decision tree model can be selected where a decision on final value is to be made based on a set of sequential input variables. Next is run the selected algorithm on training data. So running algorithm completes training and performance can be optimized by using the cross validation using a validation set of variables. Next, evaluate the accuracy of the learned function using values from test set. The function is ready to use, but after measuring the performance on a test set of variables, which is different from the training set. Then there are different common issues faced while using the supervised learning. A lot of computation time is required for training and also for classification, especially when big data is involved. Overfitting, the model may learn the noise in the data to such an extent that instead of considering it an inconsistency, it can be considered a concept for learning. Then a basic difference between the supervised and unsupervised learning. In case of an input which cannot belong to any class, instead of creating a new class, the model will include it in one of the existing ones. So these are the common issues which we are facing while using the supervised learning. There are some practical applications of supervised learning. So for beginners, at least probably knowing what does supervised learning achieve becomes equally or more important than simply knowing what is supervised learning. So a very large number of practical applications of the method are as follows. So detection of spam. detection of fraudulent banking or other activities, medical diagnosis, image recognition, predictive maintenance, and with increasing applications each day in all the fields, machine learning knowledge is an essential skill. What is unsupervised learning then? It is a class of machine learning techniques used to find patterns in the data, which means only the input variables are given with no corresponding output variables. Exactly opposite of supervised learning. In unsupervised learning, the algorithms are left to themselves to discover the interesting structures in the data. So it will not know that one is called shoes and the other socks, but it knows both are different categories and places them so. So even if it is an apple, if it is a papaya, or it is a guava, whatever it is just classifying it. It is just saying that it is the different one, even if the output is not there with the input. There are some applications of the unsupervised machine learning techniques which are clustering, so which allows you to automatically split the data set into groups according to similarity. Often, cluster analysis overestimates the similarity between groups and doesn't treat data points as individuals. So for this reason, cluster analysis is poor choice for applications like customer segmentation and targeting. Next may be anomaly detection, so which can automatically discover unusual data points in your data set. This is useful in pinpointing fraudulent transactions, discovering faulty pieces of hardware, or identifying an outlier caused by human error during the data entry. Then association mining. It identifies sets of items that frequently occur together in your data set. So retailers often use it for basket analysis because it allows analysts to discover goods often purchased at the same time and develop more effective marketing and merchandising strategies. The next is latent variable. The models are commonly used for data preprocessing, such as reducing the number of features in a data set into multiple components. The list of unsupervised algorithms used for clustering are K-mean clustering, hierarchical clustering, and DB-scan clustering. Next part is reinforcement learning. So it allows machines and software agents to automatically determine the ideal behavior within a specific context. And in order to maximize its performance, simple reward feedback is required for the agent to learn its behavior. This is known as the reinforcement signal. The best example of this is a game such as chess, where points are maximized over multiple moves. In a self-driving car, it interacts with its environment and, depending on its performance, reaches to destination safely. So conversely, the agent receives a penalty for performing incorrectly, such as going off the road. The advantage of this approach is that it allows an AI program to learn without a programmer spelling out how an agent should perform the tasks. There are different machine learning algorithms which can be implemented in various languages. So I have taken here the examples of those algorithms which can be implemented in Python. So objective is to just learn all the machine learning algorithms in Python programming. So let's see. Linear regression. Then we have logistic regression, decision tree, Then we have support vector machines. Then we have naive Bayes. Then K nearest neighbors. Like this, we have different algorithms, so which we can learn using this. Okay, so we'll start one by one. So all these are implemented in the Python. Okay, so first one, linear regression. It is one of the supervised machine learning algorithms in Python that observes continuous features and predicts an outcome depending on whether it runs on a single variable or on many features. We can call it simple linear regression or multiple linear regression. So this is one of the most popular Python ML algorithm and often create a line AX plus B to predict the output. We often use linear regression to estimate real values like a number of calls and cost of houses based on continuous variables. The regression line is the best line that feeds y is equal to AX plus B to denote a relationship between independent and dependent variables. Logistic regression. It is a supervised classification unique machine learning algorithms in Python that finds its use in estimating discrete values like 0 or 1, yes or no, and true or false. So this is based on a given set of independent variables, and we can use this logistic function to predict the probability of an event, and this gives us an output between 0 and 1. So although it says regression, this is actually a classification algorithm. So logistic regression fits data into a logit function and is also called logit regression. Next, decision tree. A decision tree falls under supervised machine learning algorithms in Python and comes of use for both classification and regression, although mostly for classification. So this model takes an instance, traverses the tree and compares important features with a determined conditional statements. So whether it descends to the left child branch or the right depends upon the result. So usually more important features are closer to the root. Decision tree, a machine learning algorithms in Python can work on both categorical and continuous dependent variables. So here we split a population into 2 or more homogeneous sets. We can use various functions for this. Support vector machines. So SVM is a supervised classification, which is one of the most important machine learning algorithms in Python that plots a line that divides different categories of your data. In this machine learning algorithm, we calculate the vector to optimize the line. This is to ensure that the closest point in each group lies farthest from each other. So while you will almost always find this to be linear vector, it can be other than that. So in this Python machine learning example, we plot each data item as a point in an n-dimensional space. We have n features and each feature has the value of certain coordinate. So we can plot the data set by using various commands. So naive Bayes, it is the classification method which is based on the Bayes theorem, and this assumes independence between the predictors. So it assumes that a feature in a class is unrelated to any other. So we are not having much data on this. Then the KNN, that is the K nearest neighbors. This is the one of the Python machine learning algorithms for classification and regression mostly for the classification. So this is a supervised learning algorithm that considers different centroids and uses a usually Euclidean function to compare the distance. So then it analyzes the results and classifies each point to the group to optimize it to place with all closest points to it. It classifies new cases using a majority vote of k of its neighbors. And the case it assigns to a class is the one most common among its k nearest neighbors. And for this it uses distance function. Next is k-means. It is an unsupervised algorithm that solves the problem of clustering. It classifies data using number of clusters. The data points inside a class are homogeneous and heterogeneous to pair the groups. Random forest. A random forest is an ensemble of decision trees. In order to classify every new object based on its attributes, trees vote for class. Each tree provides a classification, and the classification with the most votes wins in the forest. So here also there are different functions which we can use. So it can be implemented in the Python. So the advantage of this is it is fast, robust and easier to understand, and we can say it is relatively efficient also, and gives the best result when the data set is distinct or well separated from each other. But the disadvantage is that the learning algorithm requires a priori specification of the number of cluster centers and the use of excessive assignment. If there are too highly overlapping data, then k-means will not be able to resolve that there are two clusters. So the learning algorithm is not invariant to nonlinear transformations. So with different representations of data, we get different results. And Euclidean distance measures can unequally weight. So the learning algorithm provides the local optimum of the squared error function. So like this, there are different disadvantages. Now we will move to the applications of machine learning. That is the last part of this webinar. So machine learning is a buzzword for today's technology, and it is growing very rapidly day by day. So we are using machine learning in our daily life even without knowing it, such as Google Maps, Google Assistant, Alexa. So we have some examples available here. First is image recognition. So image recognition is one of the most common applications of machine learning. It is used to identify objects, persons, places, digital images, etc. The popular use case of image recognition and face detection is automatic friend tagging suggestion. Facebook provides us a feature of auto friend tagging suggestion. Whenever we upload a photo with our Facebook friends, then we automatically get a tagging suggestion with name, and technology behind this is machine learning's face detection and recognition algorithm. It is based on the Facebook project named Deep Face, which is responsible for face recognition and person identification in the picture. Next example is speech recognition. While using the Google, we get an option of search by voice. It comes under speech recognition and it's popular application of machine learning. Speech recognition is a process of converting voice instructions into text, and it is also known as speech to text or computer speech recognition. At present, machine learning algorithms are widely used by various applications of speech recognition, Google Assistant, Siri, Cortana, and Alexa, and using speech recognition technology to follow the voice instructions. Next is traffic prediction. If we want to visit a new place, we take help of Google Maps, which shows us the correct path with the shortest route and predicts the traffic conditions. It predicts the traffic conditions such as whether traffic is cleared, or it is slow moving or heavily congested with the help of two ways. One of that is real-time location of the vehicle from Google Map app and sensors, and second is average time has taken on past days at the same time. So everyone who is using Google Map is helping this app to make it better. So it takes information from the user and sends back to its database to improve the performance. Next is product recommendations. Machine learning is widely used by various e-commerce and entertainment companies such as Amazon, Netflix. So to predict the recommendation to the user. So whenever we search for some product on Amazon, then we started getting an advertisement for the same product while internet surfing on the same browser, and this is because of machine learning. So Google understands the user interest using various machine learning algorithms and suggests the product as per the customer interest. And as similar, when we use Netflix, we find some recommendations for entertainment series, movies, etc. And this is also done with the help of machine learning. Self-driving cars. One of the most exciting applications of the machine learning is self-driving cars. Machine learning plays a significant role in self-driving cars. Tesla, the most popular car manufacturing company, is working on self-driving car. It is using unsupervised learning method to train the car models to detect people and objects while driving. Then email spam and malware filtering. Whenever we receive an email, new email, it is filtered automatically as important, normal and spam. So we always receive an important mail in our inbox with the important symbol and spam emails in our spam box. And the technology behind this is machine learning. So some common spam filters are content filter, header filter, general blacklist filter, rule-based filters, permission filters, etc. Right? Like this. So some machine learning algorithms such as multi-layer, perceptron, decision tree, and naive-Bayes classifier are used for email spam filtering and malware detection. Next is virtual personal assistant. So we have various virtual personal assistants such as Google Assistant, Alexa, Cortana, Siri. As the name suggests, they help us in finding the information using our voice instruction. So these assistants can help us in various ways just by our voice instructions such as play music, call someone, open an email, scheduling an appointment, etc. So like this, they help us every time. And these virtual assistants use machine learning algorithms as an important part. Next is our outline fraud detection. Machine learning is making our online transactions safe and secure by detecting fraud transaction. Whenever we perform some online transaction, there may be various ways that a fraudulent transaction can take place, such as fake accounts, fake IDs, and steal money in the middle of a transaction. So to detect this, feed-forward neural network helps us by checking whether it is a genuine transaction or a fraud transaction. So for each genuine transaction, the output is converted into some hash values, and these values become the input for the next round. So for each genuine transaction, there is a specific pattern which gets changed for the fraud transaction, and hence it detects it and makes our online transaction more secure. Next comes the stock market trading. So machine learning is widely used in stock market trading. In the stock market, there is always a risk of up and downs in shares. So for this machine learning's long short-term memory neural network is used for the prediction of stock market trends. Next is medical diagnosis. In medical science, machine learning is used for disease diagnosis. With this, medical technology is growing very fast and able to build 3D models that can predict the exact position of lesions in the brain. It helps in finding brain tumors and other brain-related disease easily. Then is automatic language translation. Nowadays, if we visit a new place and we are not aware of the language, then it is not a problem at all. As for this, also machine learning helps us by converting the text into our own languages. The Google's JNEC provide this feature, which is neural machine learning that translates the text into our familiar language and is called as automatic translation. So the technology behind this translation is a sequence of sequence learning algorithms, which is used with the image recognition and translates the text from one language to another. Then is the last one, intelligent spam filters. So spam filtering has been done for years with machine learning technology. More recently, you must have observed that Google came out with the features that enable you to do smart email compositions. So you can actually have text written for you on the fly as you are writing your email. Your subjects are automatically written as well, and it also recommends to you to whom you should be sending the email. It also helps you to see if you missed someone. All these things are powered by machine learning. So that's it from my side. So thank you very much for giving me the opportunity to share my knowledge. If you have any queries related to this, you can contact me anytime. So my email ID is hodit@jnec.ac.in. Thank you so much.
Thank you very much for the lovely presentation you have sent us, ma'am. I'm very sure our participants would have found it very useful and informative. So with this, we reach the end of today's webinar and the main session on machine learning, supervised and unsupervised learning. I'd like to thank all our participants who have joined us today, and also our keynote speaker who have sent us this pre-recorded presentation, wonderfully explained and put in place. So thank you once again, ma'am. And I'd also like to thank our academic partner, United Innovators. So if you're looking for help regarding paper publication, patent filing, or research writing, research article writing, please do visit unitedinnovator.com to know more about the services they offer. So please do write your feedback, queries, and questions regarding this session to webinar@iferp.in. Please do follow IFERP on social media to know more about the upcoming webinars as well. So I thank you all once again. Have a good day.